thank you for the introduction. As Redbeard mentioned, I'm going to be talking about Fleet. If you haven't heard of Fleet, you will learn what it is through this presentation. My name is Brian Waldon. I'm an engineer at CoreOS. And I do have to say, I tend to talk really quickly through presentations, so if I start talking really slowly, I'm okay. I'm just telling myself to slow down. So as an engineer, I also don't have photos of myself. So I'm here, and there's my name. So let's move on. Before we can actually talk about the fleet, as we like to call it, we need to talk about two other major components, the first of which is systemd. So as this dog walker demonstrates, systemd takes care of stuff. It's your init system. It's a process manager, a service manager, it's a babysitter, whatever you want to call it. But first and foremost, its role is your init system. So it's PID1. It starts things, it kicks off your system. Systemd is kind of special. It has a lot more than just an init system built into it. It solves logging through its journald service, and it also lets you do a lot of really fancy coordination between your services. So you can say, I've got service X and I want it to start when service Y starts. But intro to systemd. So why do you want systemd? I mean, we have all these other init systems. We have system 5 init, upstart. We have too many init systems. So why is systemd the one that everybody should use? Well, literally all the cool kids are doing it. So doesn't that make you want to do it? But really, using it right now, we have Fedora, Gentoo, Arch, and then using it soon, Red Hat, Debian, Ubuntu. I mean, everybody really is switching. This one has won someone called it the Init System Wars. I don't remember who said that, but it's the winner. It is valiant in that battle. So systemd isn't just a different init system. Like I said, there's more built into it. Some people hate that there's more than just an init system. Some people love it. I'm more on the love it side, obviously. But the biggest value add that systemd has for us is that it lets us simplify our applications. So you don't need to worry about teaching your application to daemonize itself, no double forking. You don't have to write out a PID file and then tell somebody what that PID file is, or write out a PID file for all of your child processes. Like, no more of that. You don't have to worry about teaching your apps about syslog versus whatever other syslog thing you're using. And it's got cool stuff like socket activation. So you don't have to teach your app about TCP versus UDP or binding on some given interface. Systemd solves that problem for you. And at this point, I'd like to demo something if my machine is okay. So in the background, I was just booting up a CoreOS cluster, and I literally had 5 machines boot up on my laptop in that short introduction. So I'll just go to the first one. Well, actually, let's take a step back. I had all my windows set up so well to make this easy, and now you're going to have to watch me struggle. I have to find where all my stuff is. Aha, okay. And we'll just, cool. Okay, so systemd. So if you haven't seen a systemd, well, let me take a step back again. You interact with systemd through unit files, so there's no more of that writing out your massive sys5 bash init script thing. This is it. I mean, this is a really stupidly simple service, but it says the description of this thing is a silly ticking service, and the thing it does is loop forever and just print date every second. So as you can see, it's pretty self-explanatory. When the service starts, run that thing. And if I actually, and again, I completely hosed everything. So boop-a-doo. Okay, cool. So for those of you non-Vagrant users, first, you should start using Vagrant, and second, I just SSH'd into a VM on my machine. And I'm using VirtualBox, in case you care. Okay.
To be clear, you SSH'd into a VM that has a bunch of container size.
Not yet. There could be containers, but this is seriously just a clean VM that I just booted up. Okay. So back to systemd. I showed you the unit file next thing you do with the unit file is start it. It's your service. So I'm just going to type systemctl sudo systemctl start ticker.service, and I can ask systemd what's going on with it with the systemctl command. Systemctl status ticker.service. Okay, so, oh no. That's going to look terrible, isn't it? Okay, so systemctl status ticker.service, it's telling me a bunch of things. So it says, this is where that unit file is loaded. There are multiple paths that let you build unit files with like overlays, and it's crazy. But this is just a simple service. I put in etc systemd system. That's a path that systemd is looking at for new units. And I'm using the terms unit and service interchangeably. Unit is the generic term for a thing that systemd can do something with. A service is like an implementation of a unit that it runs something. So I started ticker.service. You can see that it's loaded from this path. These states may not mean anything to you, but it's active and it's actively running. So there are different levels of preparedness a service can have. It can be preparing to start, it can be started, it can be shutting down, it can be cleaning up after it's shutting down. But again, this is the simplest thing you can do. So I mentioned before that systemd solves logging for you as well. So I can use a tool called journalctl and ask it what the standard out and standard error output of ticker.service has been since it started. So clearly I can see a log of when the thing started and who was logging that, and I can see the actual output of ticker.service from the beginning. And it's seriously been printing every second like I told it to. Clearly this is more interesting if you're doing something other than printing date. Okay, so that's systemd. We've joked that we really need to start a book club at CoreOS, a book reading club. I don't know what it's called, an Oprah's book club for systemd, because the docs are just so incredibly extensive. I think I know what something does, and then I don't, and then I do, apparently. So please just go read through systemd docs if you're really interested. It's too incredibly difficult to explain right now. Okay. All right, jump back to the presentation. So back from demo land. So we just went over systemd. I said there were two parts, so I gave it away. But the next part is etcd. Etcd is our distributed consistent key value store that we build into every CoreOS instance. So it's there, use it. Assuming that you've actually built your cluster correctly, it is already clustered for you. Etcd is really powerful for many reasons that should be obvious. If they're not, it gives you a distributed consensus engine. So I can write into one path, and somebody else reading that path will get that information. I said it's consistent. It is actually consistent. The internal consensus is driven by the Raft protocol, which is like the Paxos protocol. It's just a distributed state machine that lets you decide what the current state of something is. Etcd was like, the original pitch was it's /etc for your entire cluster. You can't have /etc without distributed locking, so those two things are etcd. And moving on from that, I'm gonna go struggle through another demo. So, I apologize that you have to sit there in silence and watch me drag windows around. Oh, Jesus, okay. Okay, cool. Back on track. So, I'm on two different machines here. Got CoreOS 2 on the left and CoreOS 1 on the right. Now, like I said before, with the caveat that you have to set your cluster up correctly, etcd is there. So I introduced systemd earlier. What a surprise. We use systemd natively to run etcd. So there's our etcd service. And there's some interesting logs there, but we don't need to look at those right now. The way you interact with etcd is through a tool called etcdctl. It's also got an HTTP API that you can talk directly to, but this is much prettier for demos, clearly. So there shouldn't be anything here. Well, there will be stuff here, but if I just get, I can list the entire, I can't list the entire key space. I can list. Okay. You guys can yell at me when you see the typos. Okay. So as you can see, we have a file system like structure here. So clearly there's something called update engine that's already using etcd. We're not going to mess with it, so I'm not going to set that key, but let's just set another key, etcd-ctl set foo bar, like simplest thing we can do. And then let's just get foo. Oop. So we're on the same machine. That makes sense. That doesn't really prove anything other than there's some HTTP API returning what I put to it. So over on CoreOS, get foo, and wow, there's bar. So etcd is up and working. It's functional. That's amazing. So now that we have a distributed, consistent, all those buzzwords, key value store, what's the interesting stuff we can do with it? Well, locking is interesting in itself, but how about we use this feature called watch? And with no setup, I'm just going to do it. So I'm going to start watching this key. It's effectively a long pull HTTP request. So an HTTP request, it doesn't time out until it gets a response. Well, it's not a timeout, it just closes. But if I come over to the other servers, ctl set foo baz, wow, look at that. So I set a key and immediately, well, by human terms, immediately the value was available on the other side. So that's pretty cool. Let's get back to our presentation. So, nope. Okay, so let's recap real quick. Started with systemd, it runs things. etcd coordinates things. I didn't do a lot of coordination. You could see I set a key on one machine, it showed up on another machine. That's pretty cool. Put those two things together, and you get Fleet, apparently. So Fleet, from the 30,000 foot view, is etcd, like I showed before, systemd, and then this big piece of goo in the middle. That's Fleet. This isn't really showing how things are deployed across independent machines. It's just conceptually, Fleet talks to one etcd, multiple systemds, and makes magic happen. So to trigger this magic, you write a unit file into etcd. So you saw me before start that simple ticker.service directly with systemctl by putting it in etc systemd system. Apparently, I can put that in etcd, and Fleet will pick it up and do something with it. So Fleet at a high level is coordination across the cluster. So it's going to take that unit, figure out what to do with it. Maybe it's got some extra behaviors built into it that Fleet needs to make sure actually happens. But it's going to do that orchestration for you. Fleet is also a good way to see your a rough cluster-wide health status. If you're asking Fleet to start your units for you and they report failed, then that's one place you can go and clearly something's wrong. So more importantly, when you're building large distributed systems, you don't want to care about individual machines failing. You can't care about that, because once you hit a certain level, it's unsustainable. So Fleet is intended to be that abstraction between the individual machine building blocks and the applications that you actually want to run. So, surprise, another demo. Okay, I remember what I was going to do. Again, I had my terminals all set up, and then, then life. Okay, found it, guys. Oh, I don't even need this one. Okay, so I'm sitting in a terminal on my laptop right now. I'm still using those same 5 machines that I booted earlier. None of the stuff that we did to it is going to hurt this demo, I hope. And I've got a client, and specifically FleetCTL is a client that talks to etcd in my cluster. There are future ideas of adding HTTP APIs to separate clients from the actual backend system. Absolutely going to happen. Right now, FleetCTL is talking directly to etcd. So I have a directory sitting here. Oh, yeah, there it is. Full of these ticker services. I wonder what those could be. Ticker.1, and it looks pretty much the same. It's the same exact start. It doesn't have a description, but it does have this other crazy thing down here called xfleet, and it xconflicts. So I'll let you all think about what that's going to do while I actually start this. CTL start. Oh, where am I? Yeah. Okay. Nope. Don't mind that. I'll explain this magic here. I'm setting an environment variable, which is essentially how I configure fleetctl to point to the SSH port of one of my VMs. And fleetctl is going to set up an SSH tunnel for its HTTP connection through this host to talk directly to etcd. Sorry if that was confusing. So it's set now. I bet this is going to work. Oh. Oh yeah. Cool. Oh. So at this point, you can see it's actually establishing an SSH connection. It's prompting me. Vagrant has magic private keys, so there we go. Okay, so fleetctl start. I had 4 services sitting here in this directory. They're all these stupid little ticker things, but fleetctl is coordinating. Sorry, fleetctl is not coordinating this. fleetctl is asking Fleet in the cluster to start these 4 services, and it's going to sit and listen to etcd for that to actually happen. So you saw it sit here and slowly pause. That's because I'm taking up all of my memory for VMs right now, but I actually got a response. So ticker.1 started on 101, 2 on 104, 3 on 103, 4 on 102. So clearly these are all on different machines. And if you guessed xconflicts makes that happen, you're correct. And fleetctl is effectively systemctl. We're opting in, we're implementing the features that we actually care about of systemctl, but I can list units. And see all of these services we have this special state column, but they were launched in the cluster. This is just the same systemd status that we saw before. So it's loaded, active, running. This didn't have a description, remember, and we already saw this. Ticker.1 is running on machine 101. So we saw journalctl earlier, so I bet we can run systemctl journal ticker.1.service, and I'll actually thank you, go. I will follow that log. So every time it ticks, it's actually streaming the logs back to me over an SSH connection and printing it out for my enjoyment. I can fleetctl status ticker.1.service. And that, again, that's the same exact status that we saw before. Now, I said before, Fleet is intended to solve the cluster level problems for you. So Fleet's not useful if I can't shoot a machine and see a unit migrate. So let's shoot a machine and see a unit migrate. So I'll do it in another terminal so we can keep this output. Oh, okay. So remember, I'll shoot this one, okay. Destroy. Okay, so I just went over there and, basically pulled the plug on one of my VMs. So it's going to take a second because we don't want to be too happy-go-lucky with rescheduling services, because that can actually be a little bit more harmful than waiting 5 seconds and seeing if that machine was just gone or sleeping. So I'm not going to run list units yet, but like I was saying before, Fleet is supposed to be solving these problems for you. Anybody that wants to build real distributed systems can benefit from this kind of work. People building small distributed systems, small systems that you don't realize should be distributed or could be distributed, can benefit from running on Fleet because it's building these primitives for you. So if I run list units, oh yeah. So remember ticker.2 is running on F19A1, and now it's running on B3BFE. So back to demo. Wait, done with demo. Back to, yes. Okay, that's it. Demo worked.